In this section, we're talking about three big relationships when we have angles formed in circles. We're going to start out with this first one, which is the relationship when a tangent meets a chord or a secant. So if we look at this picture over here, this is our tangent line, and it's meeting a chord or a secant right there. And this point where they meet, again, is the point of tangency. So what this creates is an arc that's being intercepted, and then it creates an angle. And so just like with an inscribed angle, this is the relationship that is true. The measure of the angle is 1/2 the measure of the intercepted arc. So for example, if this arc was 100 degrees, that angle would be half of it, would be 50 degrees. So let's look at a couple of examples of this. Start on this one. So it wants me to find the measure of angle FGH. So FGH is right here. Notice there that we have a tangent, ray FG, and a chord, HG. So I know that this arc here that is cut is 90 degrees. So the angle created is going to be half of that. So that angle should be 45 degrees. Now I want to find the measure of an arc, so going the other way. I know that this angle here is 75. So to go out to the arc that was created, which was arc IJ, we need to do the reverse. So we're going to double that. So 75 times 2 would be 150 degrees. And that's the basic relationship when we have a tangent meeting any chord in a circle. So let's look at another one. So we've got a tangent here. We've got a chord right there, and we want to know what happens when they meet. So first I'm going to find the measure of angle CBD. I know that the arc that is cut right here is 240 degrees, and so this angle is going to be half of that arc, so that angle has to be 120 degrees. Now I'm going to look at the measure of arc BD. Well, I know that this arc here is 240. And so this arc BD is going to have to combine with the one I already know to make a full 360 degrees. So this is going to be 360 minus the 240 we already know, which is 120. So BD here is 120 degrees. Now, what does that mean the measure of angle ABD would be? Well, the intercepted arc is 120, so that angle is half, so that's 60 degrees. So let's try one more example, and here we want to find a bunch of angles. So starting with PRT. PRT is right here. I know that my subtended arc is 100, and so when I look at the angle that's created, that angle is going to be half of the arc, which is 50 degrees. Now we're looking at PRQ. That arc is 170. So I'm going to take half of that, which would be 85 degrees. Now there's a few different ways to think about the last angle. You could think about the fact that we already know that this is 50 and this is 85, and those three need to add to be 180. Or we could think about the fact that we already know that this arc is 100 and that's 170, and that the whole circle needs to add up to be 360 degrees. Either way, you're going to get the same answer. So I'm going to use this relationship here. So I know that this is 85 and this is 50. So together, those are going to combine to be 135. We know altogether those need to be 180, so I'm going to subtract those. And so this is equal to 45 degrees. So our next theorem talks about what happens when two chords or two secants intersect on the interior of a circle. So let's look at this picture to see what it's saying. So if we want to find this angle, or its vertical angle, because those are going to be the same measurement, what we're going to do is we're going to look at the two arcs that those segments cut. I'm going to put my arc symbols in there. And we're going to just find the average of those arcs. So when we add those up and divide by 2, this is another way to say the average of the arcs. So if I look at this, Let's look at this example. I want to find angle QPR. It's this one here. So the two arcs are 70 and 40. And so I'm going to average those. I'm going to divide by 2. So that is 110 over 2. And so that angle is 55 degrees. Now remember, if this is 55, its vertical angle is also 55. So there's a lot of information we can get from that. So let's try another example. Let's look at this one. I want to find angle VUW or YUV. So this is my angle. I'm going to look at the two arcs that those chords make, and I'm going to average them. So 78 plus 154, and I'm going to divide by 2. And so when I do that, I get that the measure of my angle is 116 degrees. So there are some other ways they can ask us this. Let's take a look at this example. So now the unknown that I have is my arc. So we still know that this angle should be the average of those two arcs, right? So I'm going to set up that into an equation. So I'm going to say the angle that I know, which is 90, equals one of the arcs plus the other, 100 plus x, over 2. And 90 is the same as 90 over 1, so I can think about this like a proportion and cross multiply that. So 180 would equal 100 plus x, and so x equals 80 degrees. Now you can also think, okay, this needs to be the average. So this is 90. 90 and 100 are 10 apart. So 90 and x need to be 10 apart. That would be another way to figure out 80. But if you need to solve it algebraically, or if the numbers aren't quite so easy, you're going to want to take this approach to it. So let's take a look at one more like that. So I want to find x, that's one of my arcs. I know this angle is 140, so I'm going to average my two arcs, 160 plus x over 2, and set that equal to my angle. 140 is the same as 140 over 1, so I can cross multiply those. So 280 equals 160 plus x. Subtract 160 from both sides. And so I get x equals 120 degrees. And I can check myself because 60 and 140 are 20 apart. And so 40 and 120 would also be 20 apart. So now for our last set of theorems. And this works in all three of these cases. If I have a secant and a tangent, two secants, or two tangents. If they intersect in the exterior of the circle, the measure of the angle is half the difference of the intercepted arcs. So the measure of the exterior angle is half of the bigger intercepted arc minus the smaller intercepted arc. And I'm going to make my highlighter just a little bit smaller here so I can be a little more precise with those. So here's my bigger intercepted arc, and there's my smaller one. The same goes for this. To find the exterior angle, I'm going to do half of the bigger intercepted arc and the smaller intercepted arc. And notice intersected means it's staying between those two lines. Last one, here's my two lines. So my bigger intercepted arc is here, and my smaller is right there. So if I look at an example, and I'm actually going to start with one like number 10. Here is my bigger intercepted arc. Here's my smaller one. So the exterior angle is going to be half of the bigger intercepted arc minus the smaller intercepted arc, which is half of 80 degrees. And so x equals 40 degrees. Let's look at another one. Let's look at this one. So exterior angle is what I'm looking for. Here's my bigger intercepted arc, but I don't know how big my smaller one is right now. So what I know is that the whole circle is 360. And so I'm going to subtract out the 230 I already know. So that other angle is going to have to be 130 degrees. And I'm going to just shrink this up so I have a little bit more room. So now to find angle x, I'm going to do half of 230 minus 130, which is half of 100. And so angle x is 50 degrees. So let's look at one where we have a missing arc. So maybe one like number 9. So I know the exterior angle is going to be 1/2 of the bigger intercepted arc minus the smaller intercepted arc. Now multiplying by 1/2 to undo that, I'm going to multiply both sides by 2. So 70 equals 150 minus x, because here my 1/2 and my 2 will cancel. I'm going to subtract 150 from both sides. So here I get negative 80 equals negative x. So x equals 80 degrees.